Hello students, how are you? I hope you all are doing well. My name is Aviraz. Today we will gonna solve a test paper which names Brahma's test effective 5. We will look after the solution and explanation too. So without wasting time, let's get started. Now, first I will clear you one thing. Basically, I will try to solve as much as question as possible in physics section. We will have the explanation and answer too. Through my explanation and answer, you will able to help solve future question related to this question. It will help you in your future question to solve a question which is related to it. So let's get started with our first question. As you can see in the first question, it is asking, first we will understand the question. In the figure, if the surfaces are frictionless, means it is telling about this surface, it's frictionless, means there is no friction, means mu is almost equals to 0. Okay, the ratio of T1 and T2, it is asking about the ratio of T1 by T2. Okay, so let's solve it. As you can see, we have three blocks. Let's name it 1, 2 and 3. We know that tension forces are internal forces. So it will not generate the acceleration. We know through the Newton's second law, only the net external force can generate acceleration on the system. You can see that in the whole system, there is only one external force, that is F. If we break the component of F along here as theta, it will become F cos theta, and perpendicular to it, it will be F sin theta by vector breaking component method. So we can easily find the acceleration. Acceleration will be net external force by total mass. We are finding the acceleration through which it will all move together. We have in the horizontal direction, there is F cos theta. You can say it A in the x direction upon total mass. You can say m1 plus m2 plus m3. Let's say A. We don't need to use it a lot. I'm just telling you for an explanation. We have to find the T1 and T2. Let's study about T2. It is of mass 3 kg and the force is acting on it is T2. As you can see, the only force that is accelerating this body is T2. We can write by equation of motion F is equals to ma. Applying here, we get T2 equals to m2 into A. M2 is here 3 and A is, let's suppose it A. This is our first equation. Now we want T1. For T1, we can calculate it out. Looking on the second block, which is 12 of kg, there is T1 acting on it and there is T2 acting behind on it. Okay, now it is moving with acceleration A. Now writing the equations, we know that T1 minus T2 equals to ma. It's m, let's suppose its mass is, it's m1 actually here, and it's m2. From here we can easily get T1. T1 is equals to m2a plus m1a. From here we put the value of T2. So T1 is equals to m2 plus m1 into a. We get T1. Now we need to find out the T1 upon T2. So T1 is equals to m2 plus m1 upon, in the bottom we have m1. As we know, m1 plus m2 is equals to 15 upon m1 is equals to 3. It's become 5 by 1. So our answer will be 5:1. The correct option will be option number 4. I hope you have understood the explanation also. Now moving to the second question. In the second question, we have an explanation, or you can say a conceptual based question. So we'll try to understand the concept related to it. First, we need to separate this out so that you will don't have any confusion related to it. Okay. Now moving to the second question. First thing, consider the following statement. Choose the correct option. Okay. We have statement A. In intrinsic semiconductor, the number of free electrons. It is talking about intrinsic semiconductor. Okay. The number of free electrons per unit volume is equal to the number of holes per unit volume. Yeah, this is the correct statement for an intrinsic semiconductor. The electron density and hole density, if I asked about it, is equal. Now, moving to the another statement, that is our statement B. In N-type semiconductor, here it is Ne greater than Nh. No, this is wrong. You know, in the N-type semiconductor, in N-type, you know, the number of electrons is much larger than number of holes. So statement B is an incorrect statement. So option 3 will be correct, as statement A is correct while statement B is incorrect. Now moving to the next question. Separating it out so that you don't have a confusion. Okay, let me write also another explanation. And for p type, we know number of holes should be greater than equals to number of electrons. Then the charge carrier density or charge carrier as a whole will be greater than for an electron. Now moving to the third question. For the third question, we have if the temperature of liquid rises, okay, temperature is increasing, then the viscosity, yeah, we understand that when the temperature increases, the viscosity of the liquid decreases. As we increase the temperature, the viscosity of the liquid will decrease. Simply, so our answer will remain to be option 2. Means that when the temperature of the liquid rises, its viscosity decreases. Now moving to the next question. Okay, let me use another way to separate out so that I don't have to use different colors always. Okay, now moving to the fourth question. If the momentum, if P represents the momentum, A represents the area, T represents time, are they taken to be the fundamental quantities? Okay, then the energy has a dimensional formula. Here we need to find out the dimensional formula of energy in terms of momentum, area and time. Okay, getting my point, getting the question? Because you know that in the fundamental units or fundamental quantities we have 7, like mass, time or length. These are the fundamental, but here momentum, area and time are taken to be fundamental quantities. So we need to understand about the energies dimensional formula in terms of these values. So let's write one by one and find the value about it. Okay, we know for the dimension of energy, if we want to calculate the dimension of energy, it's simply the work by the force per unit time, sorry, force into displacement or dot product of force between displacement, and it can be written as a ml square t minus 2. This is the dimension of energy. Now let's write the dimension of momentum. Okay, we know momentum is mass into velocity. Then for the mass, that is m, and for the velocity it's lt minus 1. Okay, now writing time, time is simply it is a fundamental quantity. For it, m0 l0 t1. This is the for the time. Now we want to write the dimension of energy in terms of, oh, we left area. Area has the dimension m0 l square t 0. Now we want to write the dimension of energy in terms of p, a and t. Now let's start. Let's assume as you have done in your classes, let's assume that energy is proportional. We can use equal to by removing the proportional with the proportionality constant, is proportional to p to the power. We have the just you can see in the question, we have momentum, area and time, p to the power a to the power b and time to the power c. We need to find the value of a, b and c. Let's start. Okay, when we remove the proportionality, it becomes k times p to the power a to the power b, t to the power c. Now moving ahead, we know the dimension of E, that is m l square t to the power minus 2, and we know the dimension of these all quantities. We know the constant dimension is 0 0 0, m to the power 0, l to the power 0, t to the power 0. So writing it out, that is p, a and t. So for the p we can write m l t minus 1 to the power a. For the a we can write m l square t 0 to the power b. For p we can write m0 l0 t to the power c. On equating, after equating we get the values of a, b and c, and once we get the values of a, b and c, we can easily I will do it in like next slide. We can say it. Move ahead. Okay, here we can do it. Okay, after removing it, after solving it, we get, you can a is equals to a is equals to 1. You can easily solve it out. I have done it previously. B is equals to 1 by 2 and C is equals to minus 1. From here we can easily see that energy is proportional to, or like proportionality, if we use p to the power a, then p means p to the power 1, or p, and then we have a, area to the power b, yani means 1 by 2, and time to the power minus 1. So it's become p power 1 a half t minus 1. Then option 4 will be correct option. So our answer will be 4. The concept is very simple. You need to write all the dimensions of different quantities in terms of fundamental quantities. Then you need to find out the dependence, the power of the momentum, area and time to get the relation between energy and power, area and time. Now moving to the next question. Okay, here the question is asking about find the tension in the rope as shown. Here G is 10 meter per second square. You need to find out the tension. If we made the FBD of it, there it is 5G. Okay, there it is tension. Okay, and there it is gravity. Okay, and there it is force. We need to simply force is given, like we can write the value of force in the equation and we can easily find the tension. We can easily solve it out. Okay, we know that. Okay, it is not accelerating. G is below, I know, but it is not accelerating. So containing an equilibrium condition, we can easily write as F is equals to mg plus t. Force is 40, mass is 50. Okay, 5 into 10, and it means 50, and P for tension. From here we can easily find out that the tension will become to be minus 10 Newton. The tension will become to be minus 10 Newton. So you can see that tension is not acting here. Basically, the downward force is greater than the upward force. Means like the mg is greater than the force, so it will not get up. If you put a block that has a weight of 50 kg, sorry 5 kg, or force of 50 Newton, and you are trying to pull it up with a force of 40 Newton, it will not go up. So the tension will become 0. Here the string slacks and there is no use of string, and the answer will become here 0. Okay, many of the students have marked -10 if it is written in the option, but that's the wrong answer, because you know the concept of tension. In the case of tension, it only acts when there is a tension in the string, there is some stress or strain in the string. If it is not there, the tension will 0. Tension does not contain the negative value. Okay, now moving to the next question. Here we need to find I1 by I2 in the circuit. Here the concept used, if you ask about the concept, it's simply KVL and KCL. We need to use the KVL and KCL, and here I1 current, here I2 current. We simply need to use the KVL and KCL. Now solving it out. Okay, yeah, we can understand in this way, like we have a circuit here. Let's redraw it for better understanding. We have a circuit here for 5 volt. Okay, we have a circuit. I am trying to explain as much as possible within a given time. Okay, so that you can also learn some concept from here. So let's connect with it. Okay, it's 2 ohm, it's 5 volt, it's 5 volt, it's 30 ohm, it's 10 volt, it's 15 ohm, it's 5 volt, it's 5 volt, it's 5 volt. Or here it is mentioned I1 and here it is mentioned I2. Okay, now, okay, let's suppose we need to solve it out. First we will understand about the current through this 2 ohm resistor. Okay, current through 2 ohm resistor. Let me look whether the recording is occurring or not, so that there will be no problem in further. Yeah, it is working perfectly. Okay, let's continue. Current through the 2 ohm resistor. Okay, now think in this way. If you considered a loop in this way, okay, this is loop 1 and this is our second loop. So by solving these two loops, we have only two variables, that is I1 and I2, and we have two equations, so we can easily find out the value of I1 and I2 by solving these two loops. This question is so simple, no need to worry it about. Okay, now getting through it, if we solve it out, we can easily get the value of current through the 2 ohm resistor. Then the current for it will become to be, when you solve it out, your current will become to be I1, that will come to be 7.5 ampere. 7.5 ampere. You can easily do it. I have done it already. You can start from here, like take it K, B, C, and D, and this is E, and this is F. Okay, you can do it out. Like I1, I2, here it moves as a I1 minus I2. It will go in this way, and some current will go here, and some current will go here, and you can easily find out. In the first loop, you can easily write it like it's minus, it's plus, it's plus, it's minus, it's plus, it's minus. So when you're moving here, you get minus 5 volt, plus 5 volt, minus 5 volt, plus 5 volt, plus 2 I1. Okay, here it is minus plus, here it is plus minus, plus 30 I2 minus 10 volt equals to 0. From here you can easily get that 2 I1 plus 30 I2 equals to 10 volt. One equation from here. Another equation you can get it from here, as it is I1 minus I2. I1 I1 minus I2 current will come here, and it goes in this way, like here it is I2, here it is I1 minus I2. In the circuit it will go like this. You can take it here I3, and here it will I1 minus I2 minus I3, and you can, from here it will come I2, and then here I2 plus I3. Okay, and from here it will I1 minus I2 minus I3. From here it becomes I1. Okay, when you solve this second one, what you can do in the second case, you can easily find out in the second case. Applying in the second loop you can start from where? Let's start from A. From A, if we start it out, it's 10 volt, then it's minus 30 I2, and then moving here it's again 5 volt, then moving here, and then moving here it's again 5 volt, and then it's become like I3, 15 I3 equals to 0. From here you can get 15 I3 minus 30 I2 equals to 10 plus 10 is 20, then minus 20, it becomes this, like minus this and this 20 volt. It is equation number second. And there is I3 and I2, and there is I2 and I1, and you know another equation, that is we have I1 and I2. Then we know that I1, you can also apply the rule here, or you can say that use the Kirchhoff's current law. When you apply the Kirchhoff's current law, you can easily understand that I1 is equals to I1 is equals to, it breaks into I2 and then I3, because you know that I1 current is coming here, I2 moving here, I1 minus I2 going here, and then finally I1 minus I2, then it converted into I3. You know that I1 converts into everything, so then this is our third equation. By three equation we can solve it and find I1, I2 and I3. We need to find out only I1 and I2, and after solving it you can easily find that I1 becomes 7.5 ampere, and when you solve for the I2, it will become out to be 5 by 6 ampere, 5 upon 6 ampere. And when you find the ratio, of what, I1 by I2, it's simply a calculation. I have told you the explanation, and you can do the calculation. It will take a little bit time to calculate it out, and you can do it out. I1 upon I2, once you calculate it, it will become to be 9 ampere when you solve it out. So the first option will be correct. It's a simply calculation based question. I have just written you the equation so that you can understand how we can solve it. Calculation is upon you. You can easily do it. I have already done it, so I have just written the answer. Okay. Now moving to the second or next question. Here, the velocity of electromagnetic wave is along the direction. Okay, you know that the velocity of EM wave, it is in direction of k vector, and k vector is given by E cross B vector. K vector is perpendicular to electric field vector and the magnetic field vector. You can understand it by the vector product. So the simple answer to it is option number 2. It's a complete theoretical and like theory based question. No worries about that. Now moving to the second question or the next question. Okay, the log, let's change the color of it. The log lambda versus log E graph between the energy of an electron and its d Broglie wavelength. Okay, we need to find the graph between it. Okay, we know that the lambda is equals to h upon p. It's h upon under root of 2m e. Here e is kinetic energy. Okay, it's kinetic energy and nothing else. Okay, you need to understand it out. It's kinetic energy. Okay, now we need to find it out, the log. First, resolve it out. Lambda square equals to h square upon 2me. Now, taking the log. Okay. Now, taking the log both sides, it's become 2 times log lambda, and it's become applying the log 2 times log h, okay, and minus log 2me. You can resolve it out, it's simple, no worries, okay. Log lambda 2 log h minus, you can use the product rule, log a into b into c, log a plus log b plus log c, it's log 2 plus log m plus log e, and you know these all are constants, so simply you can get the equation log lambda is equals to log e plus, here you can write some coefficient plus some constant. This is your graph, so you can easily see that you, first of all, log can't like start with 0. You can easily see that even if your log e is 0, because it is between log, not e or lambda, it's log e log lambda, it's your y, it's your m, whatever it is, and it's your x, or this is plus c. Even if your x is 0, you still have y. Even if x is 0, wrong, wrong, it is correct, it is also correct. But let's see, it is increasing or decreasing. The question belongs to here. Okay, after this you can solve it out. From here, we need to find out whether this sign will be positive or negative. And when you solve it out, okay, sorry for that, sorry, here it will be a whole negative, c1 minus c2 minus c3 and minus log e, sorry, here a will be negative, slope will be negative, okay, here m will become to negative, I have just generalized it, will be negative. You can see from the equation log e, the coefficient of log is negative, so slope is negative, okay, so this can't be your answer because the slope is positive, so it can't be your answer. So the correct answer will be option number 3, the slope is negative, okay. So you have to also take care of the slope about it, okay. Now moving to the next question, okay. We need to find the potential difference between Vp and Vq in the network shown in the figure. Okay, we need to find the potentials of P and potentials of Q. To find the potential of P and Q, we need to get it out the value of current or the potential of, let's suppose this is point A, okay, and there is a current of 4 ampere, it is moving. Let's suppose this is point A, this is point P, and this is point Q, okay. Now VA minus VP, let's first do it in this way. We have a circuit like this, it's a simple circuit, no need to worry about. This is, redraw it, it will be easy for you to solve. Here 4 ampere current is coming, here also 4 ampere will go out, here it is I1, here it is I2. You can find the net resistance. It's a very easy question, I am just solving it. Okay, you need to find it out, simply you need to find it out I1, and then you need to find it out I2. Okay, you can find it out. Okay, let's solve it out. Oh, it will be getting very easy, like all both the resistors have the same value of equivalent, I3 8 ohm and this is 8 ohm, so it will go in this way like 2 ohm 2 ampere, or in this way 2 ampere. So if you write the potential VA minus VP, it will 2 ampere current going in this way and a drop of 6 volt, first equation. And if you write about VA minus VQ, okay, and it will become I2 will be 2 ampere and it will be 10 volt, okay. Now we need to find out of VPN, so okay, subtracting it out, simply subtract the values, or you can put the value of VA from this equation. So VA is equals to 10 volt plus VQ, and put it here, 10 volt plus VQ minus VP equal to 6 volt. This equation, okay, solving it out, we need to find Vp minus Vq. Put it there, put it there. 10 volt minus 6 volt equal to Vp minus Vq. It will become 4 volt, and the option 1 will be the correct answer. It's a simple question. You just need to have a mathematical manipulation and nothing else. Now moving ahead. Now let's move to the next question. Okay, we have question number 10, and the question number 10 is concept based. A magnetizing field, okay, we have a magnetizing field produces a net magnetic flux, okay, in a rod. The relative permeability, it's simple. You know that B is equals to mu into H, okay, mu naught into H. You simply know, and you need to find out the relative. It is asking about mu R. Mu R is equals to what happens, mu upon mu naught, and it is in the free medium, free space. But in the case of a medium, it's become B equals to mu times H, and it's mu of medium, and mu of medium can be written as mu R mu naught into H. And here you can see easily your V, net magnetic flux density or intensity, is given to be 176 upon 7, and you need to calculate out mu R, and mu naught is 4 pi into 10 to the power minus 7, 4 pi into 10 to the power minus 7, and your, okay, this will be in this way, and your magnetizing field over there is given out to be 2 into 10 to the power 3 ampere and meter. From here you can easily calculate the mu R, and once you solve it out, I have already solved it. Once you calculate it out, it will become 10 to the power 4. It's a simple formula based question, and the option third will be the correct answer. Okay, now moving to the next question is the thermodynamics question. 1 mole. Okay, 1 mole of ideal monoatomic gas. It's telling about the monoatomic. Degree of freedom 3, mole is 1. It heated at constant pressure. Telling the constant pressure of 1 atmospheric pressure is given. Temperature difference is given. Then a total change in internal energy. You just need to use the total change in internal energy. Okay. First, let's separate it out. First, you need to understand that total change in internal energy. You can calculate it out. NCV delta T. Simple. You need to calculate CV. CV for it is simple. F by 2 RT. That will be 3 by 2 RT. Oh, sorry, CV. F by 2 R. You know the formula. CV equals to F by 2 times R. You can easily solve it out, and once you solve it, delta T, you know the temperature difference in the Celsius or the temperature difference in Kelvin will be the same. So delta U equals to mole is 1, and the pressure, and no use of pressure, simply 3 by 2 times R, and then simply when you put the value of delta T, it's become 100, and when you put the value of R and solve it out, you will get the value of 12.48 into 10 to the power 2 joule. Option second will be the correct answer. It's a very simple question also. Now moving to the next question. The de Broglie wavelength associated with an electron. Okay. Here we know that H upon P under root of 2m kinetic energy, H upon P 2m electron volt. As it is talking about the potential difference, so I am just taking it out. Here you can put the values. This is mass of the electron, rest mass of the electron. This is Planck constant, 6.604 into 10 to the power minus 34 is a Planck constant. When you put the all values, you can easily put it and solve it out. This is a charge of electron and potential of 81 volt. I have already calculated it. Let's see. Calculation is upon you. I am just here to tell you the answer and the explanation and the concept behind it. Your important point is to understand the concept and the formula that is used here. Calculation is upon you. You can calculate it, you can practice it. In the examination, you need to calculate it faster, and it is only then when you calculate it at your home Okay, after calculating it, you can easily get the value of 0.136 nanometer. That is option number 4 is the correct answer. Okay, now moving to the other question. It's a question based on self-induction. The coefficient of coupling between two coils having self-inductance. Okay, the self-inductance of for first is 60 Henry and 9 Henry, and the coefficient of mutual induction is okay. And the coefficient of mutual induction of okay. It is asking about the self-inductance of two coils has been given to you. One is 16 and another is 9, and you are asking about the mutual inductance of 9 Henry coil. Okay, let's solve it out. This is the question of electromagnetic induction. Electromagnetic induction. Okay, now solving it out. Okay, you know that we need to understand the formula and we need to apply it here. Okay, we have given the self inductance and we are asked to calculate the value of mutual inductance or coefficient of mutual inductance in terms of self inductance. Okay, there is a direct formula through which you can calculate it out. Let me think about the formula. The coefficient of coupling between two coils. Okay, the self inductance L1 is given to be 16 Henry, L2 is given to be 9 Henry. The coefficient of coupling. Okay, you are asking about the coefficient and you are told to be coefficient of mutual inductance 9 Henry. Okay, and the another value of M mutual inductance is given to be 9 Henry. You need to ask K. So we know that K can be calculated using M upon under root of L1 into L2. Here M is 9 Henry upon 16 into 9 Henry square. When it solve it out, it's become simply 0.75. So the K value will be, means the coefficient of coupling between these will be 0.75, means option second will be correct. There is a direct formula to calculate the coefficient of coupling between the coils that have the self inductance and once mutual inductance is given. Okay, now solving the another question. We have a bomb is projected with a velocity v at an angle theta with horizontal. Okay, it's a projectile question, you know that. V velocity theta angle. Okay, at the maximum height. Okay, at the maximum height, it's h max. Simply you need to use the h max. Okay, it's exposed into two parts. At a maximum height, it explodes into two parts. If one piece retraces its path, okay, retrace means it's come back to the same path. At what distance from the point of projection another piece will strike the ground? It is asking about the another piece. One piece is coming here, other piece is going there. It says that one piece retraces its path, means coming back to the initial position, and it is asking about the another piece where it will fall with respect to the point of projection. It's a simply center of mass conservation, center of mass conservation based concept. You need to understand the equation and you need to easily solve it out. Okay, you know that the center of mass will move in the same parabolic path as the moving by the initial body, or you can say the bomb. The center of mass will move in the same path. So by applying the conservation of center of mass, you can easily tell that m1, or you can say ma plus mb into x center of mass will be m1 or ma x1 plus mb x2. You need to find the you are given that x1, you are given x2, you need to find out, you know, about the center of mass and you know the masses. You can easily write that center of mass will fall here and it will be your range. So m1 and m2 will be what you can say, it's explode maximum at two equal parts. Okay, it's become 2m. Okay, and xum is equals to r. Okay, center of mass will follow the same path. Okay, and simply, okay, ma is m, x1 will be 0, mass will be same. Okay, m, second will be m, and its value we need to find it out. And let's suppose its value will be x2. So when you calculate it out, x2 will become 2 times of r. And you know the formula of r. R is simply u square sine 2 theta by z. By putting it here, v square sine 2 theta upon z. 2v square sine 2 theta. 2v square sine 2 theta upon z. Option second will be the correct answer. Now moving to the next question. I hope you understand this solution of it. Okay. Again, it is a question of AC current, or the concept asks here. Let's see. In the following circuit, the RMS value, concept of RMS value of current has been asked here. Okay, it's a basic concept question. Let's see about it. You know that IRMS is equals to VRMS upon Z. As in the question you have mentioned here, the IRMS equals to VRMS upon Z. Okay, now you need to calculate it out Z first. It is LCR, sweep LCR circuit. You need to calculate it about Z. Z is equals to under root R square plus XL minus XC whole square. Once you calculate it out, Z comes out to be 2 under root ohm. I have already done it. It's simply calculation. My goal is to understand, make you understand the concept and reasoning behind it. And once you calculate the VRMS, so VRMS is the average value. V is given to be 220 volt, 220 sine 100 pi t. Okay, so it is the value of V naught, and we know that a VRMS for this case is V naught upon root 2. V naught upon root 2. So from here we get IRMS is equals to VRMS, means V naught, yeah, means 220 by root 2. Okay, into Z. Z becomes 2 root 2. It's become 2 4. 220 upon 4, and once you solve it out, it will become like, second option means 55. Yeah, 55 ampere. It is asking about the current. Yeah, 55 ampere. So option second will be the correct answer for question number 15. Okay, now moving to the next question. The question is energy stored per unit volume in a stretched wire. Okay, it is telling about the stretched wire. It's a question of Young modulus or stress strain. You need to understand the relation about it. It's a concept based question. It's, let's suppose it is a wire having Young modulus y and stress s. You need to calculate the energy stored per unit volume, means energy density. It is asking about the energy density. It is asking about the energy density. Okay, energy density, you know the formula. It's a simply formula based question. 1 by 2 upon stress into strain. You know the formula used in the case. It's stress into strain. And again, you know stress, this is equation 1, you can tell. Again, you know that stress is equals to Young modulus into strain. By solving equation 1 and equation 2, you can easily get the relation delta U, relation between internal energy and energy stored per unit volume. You can easily get it. It will become 1 by 2 times S square upon Young's modulus, means S square Y by 2. That will come out to be option second, I hope. Option once again, S squared by, sorry, option not option second, it's option third, S square by 2y. It's your energy store. It's your question number 17. Now moving to the next. First, let's separate it out. Now solving the next question is the solution of this question. Okay. A proton enters in a magnetic field. The value of magnetic field is given to be 1 Tesla with a velocity of proton is given to be 2.5 into 10 to the power 7 meter per second. Theta is given to be 30 degree. Okay. The magnetic force, just a formula based question. Q into V cross B. You need to use the formula. It's simply Q V sine theta. You know the charge on proton, you know the velocity of proton, you know the magnetic field, you know the theta. If you calculate it out, it simply comes out to be 2 into 10 to the power minus 12 Newton. This is the basically option number second. I have already calculated out. You need to understand the concept or basic reasoning that is like required to solve such questions. Okay, now separating it out again so that you don't have any confusion between two different questions. Okay, now moving to this question. Okay, let's read the question. Changing the color of the pen. A charge Q is placed at a center of the cubical vessel. Okay, with one face open. Okay, one face open as shown in the figure. The flux of electric field through the complete vessel. It's a simple question. It's a simple question. You need to understand it out. Okay, let's see. A charge Q is placed at the center of a cubical vessel. It is telling about the cubical vessel. First, you need to understand to make the cubical vessel. Okay, the electric the flux of electric field through the complete vessel is one face open. Let's suppose this face is open. You know, if the face is closed, then total flux will be Q by epsilon naught. If we remove the one face, so the remaining flux will be Q by epsilon naught. It's the total flux, and if we remove the flux, it will become Q by 6. Okay, there is 6 faces here, and okay, we don't have a one. Okay, yeah, through one phase. If we remove one phase, we know that through one phase the electric flux will be Q by 6 epsilon naught, and we know the total flux, that is Q by epsilon naught. If we subtract the flux through one phase through the total phase, it will give the flux through other phases, and this is the required answer of it. And we can solve it out. Q by epsilon naught, and it is 1 minus 1 by 6, then it will become 5 Q by 6 epsilon naught. Means option number third will be the correct answer. This will be the answer. Now moving to the second question or next question, we have the angular velocity of a body is omega. Omega is given. Let's separate it out. Okay, let's see the recording is going on or not. Okay, let me check the recording actually. Okay, it is going perfectly. Okay, let's see. Omega is given. Let's separate it out first. Okay, omega is given. Omega of the body is given 2I cap minus j cap plus 5k cap. Okay, under a torque, let's see the torque. Torque is given to be itna. Let's write the torque here, and again we will write the omega. Torque is 5I cap minus 2j cap plus 3k cap, and omega is given out to be omega is given out to be 2I cap minus j cap Okay, 2 I cap, 2 I cap minus j cap plus 5k cap. I suppose let's check it out. 5k cap, yeah. Now we are asked instantaneous rotational power. You know the translation power. Power is equals to F dot V, force into velocity. Here, if you want to know the rotational power, it's torque dot omega. Simple. You don't need to, you just have to take the dot product of these two values. And once you calculate the dot product, it will come out to be 27 watt. It's a simple question. You can perform the calculation and get the answer. No worries. So the option will be 27 watt and option 1 will be the correct answer. Okay, now moving to the second question or next. Following figure shows two processes A and B for gas. Okay, delta Q1 and delta Q are the amount of heat absorbed by the system in the two cases. Okay, in this case delta QA and in this case delta QB, and internal energy will be same. Okay, and if you want to calculate the heat, as you know, the energy equation, del Q equals to del U plus del W. Del U will be same for both, as it is the state function, so it doesn't affect the equation. It does not affect the equation. So we have del Q directly proportional to del W, and you know the area under A curve is more in comparison to area under B curve. So del W A will be greater than del W P. So del QA should be greater than QB. So option 4 will be the correct answer. It's a simple conceptual or some analytical based or graph based question. Okay, now separating it out so that it will not get fuzzy. Okay, let's move to the next question. Means like question number 21. We have question here 21. A simple pendulum. We have a simple pendulum. Okay, time period T1. Okay, let's think about this simple pendulum. Yeah, its time period is T1. Okay, the point of suspension is now moved upward. Okay, it is asking about this. Okay, it is moving upward following the relation y is equals to t square, means velocity is equals to 2t and acceleration is equals to 2 meter per second square, means acceleration is constant and mg is acting here, and now plus pseudo force will also act on it. Okay, now it's the initial time period, initial time period means no acceleration, and T2 with acceleration. Okay, it's simple. You know that the time period of for this is time period of the pendulum is 2 pi root under L by G effective. So you can easily calculate it out. T2 will become 2 pi under root L length will be same, and G effective will be what? G plus A. Simply you need to find the ratio of T1 square upon T2 square and T2 square. Once you solve it out, it's simply a simple calculation and a concept based topic, and once you solve it out, it becomes to be 6 upon 5. As you know, 2 pi will cancel out, 2 pi will cancel out, L will cancel out, L will cancel out. Here only the ratio between Z by Z effective. Okay, Z by Z effective. Simply you can calculate it out, and the answer will be 6 by 5, and option 4 will be the correct answer. Now moving to the next. As you can see, the different questions are totally based on simple concepts and more towards calculation and formula. So you need to understand the formula and the application of formula more. If you don't have read too much deep concept, it's okay, but you have to learn the formula and its application. If there is some change in the formula, how you can able to do it out. Okay, now moving ahead. An ideal gas, gamma is defined to be through the process pressure and volume. Okay, it's a, you can say it as a polytropic process. Pressure is something related to this way. Okay, the value of B for which a specific heat capacity in the process 0. It is asking about a specific heat capacity to be 0. For a specific heat capacity, you know, in the general process or polytropic process, the specific heat capacity is simply written in this way. You know about it. It's simply written in this way: R upon gamma minus 1 plus R upon 1 minus n. And here you can see that n is equals to B as the power is D, and putting C equal to 0 as the question asks, the specific heat capacity should be 0. So after solving it, 0 equals to R 1 by gamma minus 1 plus 1 by 1 minus B. From here we can easily get the value of B comes out to be minus times gamma, and once you solve it out, it simply becomes minus times gamma. Here in this question you have just given a relation and you are need to ask a special situation based on the formula you studied about the general process of the specific heat or the polytropic process. So option second will be the correct answer. Now moving to the third question, means next question is 23rd question. Here, which of the logic gates represents by the following combination of logic gates? Let's see the logic gates. Okay, okay, you know this is not, and this is simply your, if you see about it, it's not, and if you break it out, this is the symbol of and, not, nor. This is AND gate, this is NOT gate, and not none NAND, and this is NOR gate. This is NOR gate, and this is NOR gate, and this is, sorry, this is OR gate, OR gate. This is no, this is NOR gate, or this is XOR gate, XOR gate. These are things to be remember, and there is like a little, most of the things really to have remember. So I have little confusion about this, but I know in the sequence way was type of gate it involved. And if you put not here, if you put not here, it will become XNOR gate. Okay, so simply it's not gate, NOR gate. Sorry, this is OR gate. This is OR, and if we put a circle here, it's NOR. This is and if you put circle here, it's NAND. These are simply you need to like you need to remember it out, and I think not don't think so important to, like once you have a lot of practice you can easily remember it out. Okay, so you here it is asking that what's the equivalent circuit becomes to be. Okay, you need to simply have a truth table. You have A, you have B, and you have final output. If you, let's suppose you have taken it to 0 and this 0 it's become 0 1 1, and it's become, or 1 1 add 1 1 0, it's become 0, and it's asking about like if you put 0 1, let's make the inputs like 1 0 1 1. That's for the 1 1, it becomes again 0. You can see it's become again 0, it's become 1. So you can see that it's acting as an AND gate. You know, in the AND gate it's product. If either one is 0, the whole will be 0. If both will be 1, then only 1. It's simply acting as an AND gate, so option third will be the correct answer. Now moving to the next question, first separating it out. It's a question I think based on the electrostat and mechanics mixed. Okay. Let's suppose a particle having charge minus q of mass m released from rest. Okay, here it is rest. Okay, from the axis of a fixed ring of charge q, and there is not at a distance is not. Okay, from the center of the ring. Okay, its kinetic energy when it reaches to the center of the. Okay, you know when it reaches to the center of the, it's minus q. Okay, it is, as you know that when it moves towards the center, its speed increases as it has a negative charge and the ring has positive charge. So its speed will increase, and also potential difference, or sorry, potential energy will decrease. So simply you need, when it reaches to the center, it has some velocity, or the maximum velocity you can say, and the minimum potential energy you can say. You need to simply apply the conservation of the energy. Simply you need to simply apply the conservation of energy, and once you apply the conservation of energy, you can easily solve it out. Okay, it's a simple like conservation of energy based topic or question. Applying conservation of energy. Let's take as initial position and center as final position. So energy initially equals to energy final. Initially you have at rest, so kinetic energy 0. Potential energy, yeah, it has potential energy. You must know the value of the potential energy on the axis, and it's simply minus q, okay, upon 4 pi epsilon naught, and then there is a r under root r. There is root er to the whole square plus r square to the power 1 by 2. It's simply a formula and nothing else. And the kinetic energy 0 everything. Finally it is at the center, and you need to have a kinetic energy, and but you know the potential energy at the center of the ring, and it's q, or you can say like 4 pi epsilon naught, and at the center is constant r. And it's, you simply need to solve it out, and after solving you can easily get the value of the velocity. Oh sorry, kinetic energy. It is asking about the kinetic energy. So you just need to get this value out and solve it out. Simply you just get q upon 8 pi epsilon naught r. I have already solved it out. So I am basically focusing on your concepts and the reasoning behind it. And it's simply the kinetic energy, and kinetic energy comes out to be q upon 8 pi epsilon naught r. I think option third will be the correct answer. Okay. Okay. Now moving to the next question. Let's see. It says, okay, you have question number 25. You have question number 25. You can see in the question number 25, a physical quantity P is described by a relation. Okay, you have any physical quantity P which is described by a relation. It's a unit and dimension, unit and dimension, unit and dimension based, unit and dimension based question basically. Okay, and it is given as a P is equals to a to the power 1 by 2, b to the square, c to the square, d to the power minus 2. If the percentage error in the measurement of A, B, C and D are itna, then the maximum percentage error. Okay, just you need to have a calculate the percentage error of what? Of P. P, you need to calculate the percentage error of P. You can easily do this. Let's suppose percentage error delta P upon P into 100. It's become 1 by 2 delta A by A into 100. It's become like if you multiply it out, it's become 2 times delta B by B into 100 plus 2 times delta C upon C into 100, and again minus, okay, sorry, 1 by 2, sorry, it's 1 by 2, simply 1 by 2 delta, no, oh, it's 2. I have misunderstood through this 1 by, here it is 1 by 2, so 1 by 2 is 2. and this is minus delta d by d into 100. You know these values, you know this. You just need to put it out, and when you solve it out, your this value will come out to be simply 9%. I have already solved it out. I'm just telling you the explanation and the answer, the reasoning behind it. I am again and again saying calculation is upon you. You can easily do and do calculation. I have already calculated it out, and simply I am just telling you the answer after calculation. Okay. You need to understand the concept used or the concept asked in the exam. Okay. Next question. A stone. Oh, let me drink first. Okay. You can read the question and try to solve it by yourself. Okay. A stone falls freely under gravity. Okay. A stone falls freely under gravity. It covers a distance h1. Okay. h2 and h3. It's a simply relative distance question. It's a very famous question. S3. In first 5 seconds, next 5 seconds, next. In the first 5th second, next fifth, total 10. Next fifth, total 15. You just need to calculate the h1, h2 and h3. You need just to calculate the value of it. You simply know in the first fifth, you just have to calculate the first fifth. You can calculate h1. It's simply initial velocity 0. You can start from here, and it comes to out to be half times half gt square. G means z, or 5 square. For h2, you can write it out half g. From starting is 10, and for h3 it comes out to be half g, and again 50 whole square. Simply h2. Okay, let's see. In the first 5 seconds, in the first 5 seconds it moves here. In the second, okay, sorry, second fifth it is asking. Sorry. h2 will not come in this way. Let's erase it out. h2 will not come in this way. Eraser. h2 will become like this. It will come like this. In the next so next fifth, so 5 square, and s3 will simply come, and 15 square minus half g, because in the fifth, 10th, next fifth, it is telling the interval, not from the starting. You need to subtract it out. Simply you understand, you need to subtract it out. Okay. 10 ka whole square. And when you solve it out and calculate the h1, h2 and h3, your h1 will become to h2 by 3 and h3 by 5 times. I have already solved it out. You know to understand the concept. h1 is first 5 seconds, h2 is next 5th second, but means t equals to 5 to t equals to 10 interval, and again it is next fifth, means t equal to 10 to t equals to 15 interval. So the answer of this question will be option number 3. Okay, now moving to the next question. Okay, it's an EMF or induction based question. Let's solve it out. You simply know you need to calculate the EMF or the current in these types of question. You just need to ask. Okay, a rod PQ. Yeah, you have a rod PQ. Okay, you have mentioned the length moving. Okay, you velocity. You have L, that is 1.25 meters. You have velocity, that is 10 meters per second. You have magnetic field also. It is constant, 0.2 Tesla. Now you have also resistance, that is 100 ohm, and you are asked to be calculated I. It's a simple formula of this question. First we have to calculate the EMF. EMF is simply, you know, it's BLV. Once you calculate it out, it's become 2 volt, and I is equals to EMF upon R, that is 2 upon 100, means 0. Okay, in the milli, I am just solving it as SI. It's become you can solve it out, 2 upon 100 into 10 to the power minus 3. So it's simply become, okay, 0. Wait. No. In this way, we do not convert. It's 0.02 ampere. It's in ampere. So if we want to calculate in milli, we know in 1 ampere is equivalent to, sorry, in 1 milliampere is equivalent to 10 to the power minus 3 ampere. So 1 ampere is equivalent to 10 to the power 3 milliampere. So if we multiply with 10 to the power 3, it's become 20 milliampere. Yeah, it's 20 milliampere, means like option third. You can easily see that they have also tried to check your conversion skills. So you need to understand or remember some conversions also. It is important. You have seen it here. Oh, it's a wave optics question. Let's see. It is asking the first diffraction minimum due to a single slit diffraction at angle itna. You have given theta is equals to 30 degree. Okay. And then for a wavelength of itna. Okay. So wavelength is given to be 5000 angstrom. You know simply the width of the slit. You know equals to d sine theta or a sine theta. You can use any symbol you want. Okay. Let's say take it a sine theta equals to L lambda. First n is equals to 1. And lambda. Okay, from here you can calculate the a. You simply need to calculate the a. It's n lambda upon sine theta, and when you put all the values and calculate it in centimeter, it will come out to be 10 to the power minus 4 centimeter. That is option number second. It's a simple question. There is no need to worry it about. So moving to this next question. It's an semiconductor question. Let's see. It's a 0 volt. It's a 0 volt. It's plus, it's minus, it's plus, it's minus, it's plus, it's minus, it's minus, it's plus. Let's suppose current is flowing in this way. So it is in forward wise. Positive is current to the positive, negative is current to negative. It's forward wise. And if it is an ideal, so potential drop. So potential drop is zero. Potential drop is 0 volt. So it's an ideal. You can simply make this diagram like this. There is no use of en diode, junction diode. Okay, you can simply make this way. It's a simple this type thing. 5 volt, 2 volt, 700 ohm, or current I. Okay, you need to just calculate the current. Yeah, you just need to have the K like KVL rule. You know, just calculate the KVL. It's a simply very basic question. You can easily calculate it out. You can see that I is can be equals to V by R. Means like potential. Let's suppose here potential 5 volt. Here potential 2 volt, 0 volt means like 5 by 700. And once you calculate it out, it's become 10 milliampere. It's a very simple question. You can easily calculate it out. Now moving to the next question. It's a theory based question. Let's see. Which of the following is true for Lyman series? You know, Lyman, Balmer, Paston, Brackett, Pfeiffer. Sorry, Lyman, Balmer, Paston, bracket people, yeah, in this order. You can remember the order. Lemon is the first series, like n equals to 1, the final order here, it would be. A series in the hydrogen, you know, Lyman series lies in which case? Lyman series lies in the UV region, and Balmer in the visible, and rest in the infra. Simply, it's the option 1 will be the correct answer for this question. Now, moving to the like question number 31. We have question number 31. In a star, all helium nuclei are constructed into oxygen. Okay, one is talking about helium, another is oxygen. If the atomic mass of helium is itna and atomic mass of itna, then the reaction energy per atom of the oxygen, it is asking you the energy released or reaction energy. Whenever you are asked the energy released, reaction energy, required energy, you just need to calculate the mass defects. First of all, you need to calculate the mass defect. Thereafter, you need to simply multiply between energy that will be delta M into, simply you need to multiply 931.5 mega electron volt. You need to simply calculate the first mass defect of it. So here delta M you can easily calculate. You know that oxygen is sorry Helium, okay, all helium. It is asking what or telling in the first scenario, even I have confused here, like its helium is smaller, so how there will be the mass, but the like energy released. But you can see here, it is telling about the all helium. Okay, so you are need to understand it like its mass of the simply you need to understand it's the mass of the reactant. Okay, is the mass of the reactant minus mass of the product, and here we have all helium nuclei constructed into oxygen in a star. In the star formation, with the atomic mass of helium, one helium is this, and the atomic mass of oxygen, then the reaction energy per atom. Okay, here you need to understand that here it is telling that all helium. So in the star system, we have four helium. Okay, four helium is converted into oxygen. So our mass defect will become to be 16 point. If you multiply with the 4, it becomes 16.0104 minus 15.999. So it will becomes to be out to be 0.000.001 U, AMU or U you can say. And from here delta I you can calculate it out 0.011 into 931.5, and once you calculate it out it will become simply 10.26 mega electron volt. I have already calculated it through calculator. You need to do it by your hand, so your calculation speed must be. Here the main concept is to understand that it is telling about the all helium, not just one helium. Okay, so take it correctly. Okay, now the mobility of free electron. The mobility is drift velocity per unit electric field of free electrons in a conductor is directly proportional to the electric field. Okay, it's asking about the directly proportional to the electric field. Okay, directly proportional to relaxation time. Okay, or inversely proportional to number of density of electron, or inversely proportional to the electric field. The mobility. What is the mobility? Mobility is the how free electrons are to move, how mobile electrons are inside any body. It is asking for a conductor. Conductor's mobility does not depend on the electric field. It depends on the relaxation time. Means in the conductor, the amount of average time available for an electron to collide is defined as a relaxation time. It's totally depend on the relaxation time. What's the average relaxation time available for an electron before colliding? So it directly depends upon the relaxation time. And you can also get a formula for it, like mobility is defined as, like, if I'm not wrong, like mobility is defined as a drift velocity per unit electric field. If you put the drift velocity, it will come out to be depend on the relaxation time. Okay, so it will depend on the relaxation time. Now, moving next. When unpolarized light gets polarized on passing through a polarized, its intensity. Let's see. When unpolarized light of I naught passing through an polarized, its gets PPL is converted into partially plain polarized light, and its intensity gets half. Option one will be the correct. So that like question, option based question. Let's see second. Means next, a second's pendulum. Okay, there is in a lift. Okay, there is a pendulum in the lift. Okay, if it is moving down with acceleration g by 2, okay, it is moving down, then the new time period. Okay, you need to understand about the new time period. Simply the same formula, time period 2 pi under root of L by G effective. In second case, the G effective will be G minus Z by 2. It's simply your Z by 2. So T1 and the T2, in the case here Z effective is, and for the T2 case it is moving downward, so acting upward the pseudo force, it will L by Z by 2 simply. It's in the second, so you can easily calculate the new time period in the terms of first time period, and it will become to be 2 root 2. Once you calculate it out, it simply becomes out to be 2 root 2 once you calculate this T2 in terms of T1. Okay, it's simple question, not a big deal to solve it. You know, just need to take the ratio of it and calculate T2 in terms of T1. Yes. Okay. or you can say T1 is given in seconds, so you can take it T1 as a 1 second, and thereafter you can calculate T2 in terms of T1, and thereafter you need to put simply you need to calculate T2 in terms of T1, and instead of T1 you need to put T1 equals to 1 second, and you get the T2. Just a calculation. Okay, now moving ahead. A small light bulb is at the bottom of a vessel in a liquid. A ray of light from the bulb travels up to the surface and moves so along the surface as a shape. So, speed of light in the medium. Okay, you need to calculate the speed of light in the medium. Okay, here this is the angle, and it is a gradient angle. So you can calculate that a sine theta equals to 1 upon mu. 1 upon mu, you can calculate it out. You can calculate it out from here. You know what angle, you don't know the angle, but you can calculate the angle from here. From this triangle you can calculate the angle. So from here sine theta you can easily get 3 upon 5. 3 upon 5. So from here mu you can get 5 upon 3. 5 upon 3. So mu you can get 5 upon 3. Now the speed of light v equals to c by mu. So once you solve it out, c by mu, it's become 5 by 3 into 10 to the power 8. Okay, wait. Okay, mu is equals to it now. V equals to c by mu. Sorry. It's 3 by 5 by 3. Sorry. Why so I'm asking, like thinking how it is getting out to be more than the speed of light in vacuum. C 3 into 10 to the power 8 upon mu is 5 by 3. So it's 9 by 5 into 10 to the power 8. So 5 1 ja 5, 4.1.8. That's it becomes out to be option second. Now we'll move to the second section, and it has some a little bit good questions when like you need to think a little bit more about on this. Okay, let's move one by one. Let's see. Two bodies are dropped in succession from height at an interval of 1 second. Okay, first body is dropped here. First body arrived here. The second body is dropped, and the time difference between them is 1 second. But the means, let's see, there is a ball which has been dropped. Once we move to the 1 second, at 1 second another ball is dropped. Okay, the relative velocity of body one with respect to, okay, you need to calculate the relative velocity. A simple question. It's simply the applying the equation of motion. For first body, we need to use v equals to u plus at. For first body at t equals to 1. So v equals to u plus at minus v, and simply for first body, and for the second body it's simply at rest. So velocity of 2 with respect to 1 is simply z, and nothing output. It's simply z. Option second is, it's simply a logical question. The answer will be g. Now moving to the second. An alpha nucleus of energy itna. Energy is given for an alpha nucleus, half mv square. Bombards heavy nuclear target of Zd. Okay, total charge is given Zd. Then the minimum distance. Okay, simply the kinetic energy converted into potential energy. Hence half mv square converted into potential energy. Potential energy kq1 q2 upon r square. It's simply k alpha. Alpha means 2e into Zd kq1 q2. Okay, 1 by 4 pi epsilon naught r square means simply r is potential energy, simply r. So from here you can calculate r, and r come out to be or proportional to 1 upon m. It is inversely proportional to the mass. Option third will be the correct answer. It's a simple energy conservation question. A big drop of radius 1 centimeter. Okay, the radius is 1 centimeter converted into 1000 small drop, converted into 1000 identical. Volume will comes up, surface energy, surface area will differ, but the volume will comes up. So you can calculate the radius of each drop once it is converted into 1000 small drop. The radius is r big and this is r small. You can calculate the r small through the volume conservation. Volume conservation, how you can? Volume of big equals to 1000 times volume of small. It's simply 4 by 3 pi r cube equals to 4 by 3 pi r small cube. From here you can calculate the r small. Okay, let's see the other question. If the surface tension of the liquid is now, okay, surface, it is telling about the surface tension. Surface tension is given as a 9 per centimeter. Okay, the ratio of the okay, it is just asking about the surface energy final upon surface energy initial. I think you don't need to calculate everything. Okay, surface energy is simply given as a final 4 pi r final is 4 pi r square into surface tension upon initial 4 pi r initial square surface tension. So you can easily calculate it out, and r final and r initial ratio between them, and it converted into 1000. It simply becomes out to be 1000 to the power. So you need to understand it. From here you can calculate the r small. R small will come out to be r small will come out to be r big upon 10. Yeah, and it's simply r big upon 10, and you can know the r final is r big upon 10, and there is this. After doing calculation you can easily calculate the ratio that comes out to be, that is 10. That option first. You simply know from here that r small comes out to be r big by 10, and once r small is equals to r final and r big is equals to r initial. So once you put r final is equals to r initial by 10, so r final square, you can calculate it out. R final square is 1 by 100. I think its surface tension is r final, r initial square, final surface energy, r final square, r initial square upon 100. Okay, sorry. It is coming out to be 1 upon, it is coming out, it is asking about the final in initial. So after conserving the volume, identical, the radius of big drop will be the radius of a big drop of radius, the radius of big drop is given. Okay, and it is converted into a small identical drop, all have radius something like that. Volume of okay, and small drops, volume of 1 2 3 4 and some 1000 volume of a small drop. It's a small, it's big, there's 1000, moving 1000 here, it's become 1 upon rb cube upon 1000. It's rb by 10, and putting it here rb by hundreds. I think it's coming out to be 1 upon 100. Once you put it out, it's coming out to be, let's take the calculation, but you know the concept. You just need to use the volume conservation and surface energy concept. Volume conservation, surface energy concept, you can easily, maybe I may misunderstood the calculation or I have done calculation wrong, but I think it is coming out to be 1 upon 100. You need to check it out a little bit. Okay, let's move to the next question. Okay, A particle of mass m and charge q is an electric field and magnetic field. Okay, the electric field is given out to be this, and the magnetic field is given. The charge particle is from origin to point P. Okay, coordinate is given. The magnetic field is work done. Okay, simply you need to understand or calculate the work done. You know, work done by the fields, because you know that like magnetic field do not do work. Okay, so simply you need to find the work done by electric field. Work done is equals to force into displacement. So simply need to understand the force. You have given the electric field and you need to calculate the force. Force is equals to q into e. The charge particle, it is telling about the particle of mass and charge. Okay, it is q, and the force q and the electric field 2 I cap plus 3 j cap. Okay, a dot displacement is from 0 0 to 1 comma 1. You can write in a vector I cap plus j cap. So after solving this, you can easily get in the terms of q, which becomes out to be 5q. It's a simple question, no need to worry about. Okay, now it's a theoretical question. The magnetic moment of a magnetic needle M, it is placed in a uniform magnetic field B in 4 different orientation. Okay, potential energy. Okay, you know, if it is in opposite direction, potential energy will be maximum for that. Potential energy is minimum for this, zero minimum for this. M3 should be last. Option third. From one you can get the answer. There is only option third that is matching with it. But you know the concept. You know the potential energy, that is minus m dot d. Minimum for theta equals to 0 degree, max for theta equals to 180 degree, 0 for theta equals to 90 degree. You can easily understand it out. Okay, now moving to the next question. What is the minimum energy required for launch a satellite of mass m from the surface of a planet mass m, a radius r, in a circular orbit? Okay, that is the radius r and the mass, its mass m and radius r. Now we want to launch a satellite which will revolve in a radius of 2r. You can simply do the energy conservation. Simply you need to have energy conservation, or you can also use the orbital energy. Like you can use the gravitational potential, you know, like given, what are the given things given, you know, minimum energy requires the satellite mass. You have given mass of satellite, mass of satellite, it's simply your small m. Mass of planet, it's simply capital M. And then initial radius, you can say that its initial radius, it's r, final, it's 2r. Or you can say altitude of r, simply altitude of r, you can use it now. Finally you can say, okay, now potential energy, final potential energy, final you need to calculate the final total energy and final potential energy, and from the difference you can easily calculate the minimum energy required. It's saying that the minimum energy, you need to calculate the final energy and the minus initial energy. Means like once it moves to the 2r orbit and once it is in r, the energy difference is required to give it so that it can get into 2r. So E final, you need to calculate this quantity. This is the answer. So E final is equals to like kinetic energy final plus potential energy final. You need to write both in terms of potential energy. You can easily write. So simply it's half m v orbital square final. I'm talking about the final, minus gmm by 3r. And once you write the orbital velocity in terms of the potential energy, it's simply half gmm by 3r minus gmm by 3r. And once you solve it out, simply you solve it out, it becomes to be gmm by 6r. Okay, gmm by 6r. Okay, gmm by 6r. Now talking about the initial energy. Initial energy, once you talk about the initial energy, it comes out to be, initial energy comes out to be, it has only potential energy, so that will be simply your G, initial energy simply G M by R. As you can see in the previous questions also, like we have mentioned G M by R. So you can calculate the E final minus E initial. E final minus E initial comes out to be Zm by 6R minus Zm by R. So it simply comes out to be 1 minus 1 by 6. It's simply 5 Em. It will be negative. Obviously, it is in orbit, circular orbit, so it will be negative mm by R. So option D will be, the 4 option will be correct. Some parts here are not visible, I know, so I am doing it here in this way. Like I have simply subtracted half Gm by 3R minus Zm by 3R, so it becomes to be Zm by 6R. I know some parts will be visible here, but invisible you are able to, like in these slides also some parts will be invisible, so you need to a little bit manage. I have told it through my mouth, but yeah, you need to little bit understand it out. Okay, let's moving to the next question. You can calculate the fourth option will be correct. The mass of the bob of simple pendulum of length L, if the bob is left from the horizontal position, okay, then the speed of bob the tension thread at the lowest position. Okay, it's a simple question. It is here initially, and it's the initial position and it's the final position. You just need to apply the energy conservation. Energy conservation. You need to apply the energy conservation. Now let's see what has been asked here. Simply you need to understand what has been asked here. You need to simply apply the energy conservation here. Okay. Work energy theorem or energy conservation. Lowest position will be speed. Okay, it is asking about the speed, so simply you need to apply the initially the kinetic energy 0, height mgl you can use, or finally it has velocity half mv square and potential energy 0 if you take is a reference, then say 0. From here you can calculate the velocity. Velocity is come out to be root 2 gl, and tension here is mg plus mg here below mg, and there is then mv square by r mv square by L. And once you calculate the tension, it comes out to be, we put the value of V from here, and it comes out to be 3 mv. So root 2 gl and 3 mv. Option first will be the correct answer. Now solving the question of 43, it's a simple like circuit based question. If the power dissipated in the 9 ohm, okay, resistor is given as a 9 ohm, okay, power is given as a 636 watt. You can calculate power is equals to V square by R. From here you can calculate the V, that is under root of power into R. From here you can calculate the potential difference across the 9 ohm. This potential difference will be same as this. So you can calculate the potential difference from here, that is along 9 ohm is equal to the potential difference along 6 ohm. So potential difference upon 2 ohm will be total potential minus potential difference upon 9 ohm. And once you calculate it out, it will simply become to be 10 volt. As V is simply here, it is given as a, you need to calculate the V first. You can calculate the V by using like Kirchhoff's law, or you can say, okay, you can use using the Ohm's law. V equals to I into R equivalent. So R equivalent you can calculate 96 R1 R2 upon R1 plus R2 equals to 54 upon 15 plus 2 ohm. This is R equivalent. R equivalent, simply you need to calculate the R equivalent. So R equivalent you can calculate, and thereafter you can calculate the thereafter you can calculate the potential, or you can calculate the current from here. You know the potential through 6 ohm or 9 ohm, so you know the current I along the 6 ohm is equals to V along the 6 ohm by 6 ohm, and you don't need to use this. I think like I previously thought that you need to calculate it out, but no, you don't need to use this. You simply know the potential difference and the resistor. You can easily use the ohms law to calculate the current, and thereafter you can calculate the potentials also. From here you can get I6, and simply I9, for I9 ohm you can get V9 ohm by R9 I9. So I total will be I6 ohm plus I9 ohm, and V total will be I total into R total. From here you can get V total, and when you put V total here and solve it, it becomes 10 ohm. So you can easily do the calculation. There is nothing in the calculation. You simply need to do it. You need to calculate the root, and thereafter you can calculate it out. Okay, now moving to the next. Two charges, this are separated by the neutral point. Okay, you need to just calculate the neutral point and the neutral charge and nothing else. It's a simply electrostatics equilibrium problem. Okay, let's see. 2 microcoulomb charge here, and here 8 microcoulomb charge. Okay, and you know it's both are positive, so you can consider the neutral point near to something this, like let's suppose they are separated by 6 centimeter, and suppose x from this distance and 6 minus x from this distance. So you can calculate, let's suppose it's q charge. Net force on q you can put it 0, and net force on q will be like in upward here direction. You can calculate k q q kq1 q2 by r square means x square बराबर k q and q upon r square means x 6 minus x to the whole square. Simply cut this out, and it will become out to be 2 by x square equals to 8 by 6 minus x to the whole square. Simply it comes out to be this, and after solving this you can solve it out using the quadratic, and there is also some formula related to calculate the neutral point. And neutral can be calculated by d under root of n plus 1. Simply here is the d is the distance, you can use it, neutral point formula. D is the distance and n the ratio to the big charge to the small charge. D is equals to the distance, n is the q big upon q small. So from here when you put the d is equals to 6, simply d you can put the d is equals to simply 6, and big charge is 8 by 2, that means 4 under root of 4 plus 1. It comes out to 2 by 3. It becomes out to be 3 centimeter. Neutral point is 3 centimeter, and once you know the neutral point you can easily calculate the charge. What amount of charge neutral point from here x. Okay, you don't need to calculate the q small q, you just need to calculate the x from where it is 3 centimeter. X is come out to be 3 centimeter, and we have taken x from 2 microcoulomb. So the answer will be 44. It is from like once you calculate it out. Okay, 3 centimeter from its x, and you can calculate 6 minus x equals to 3 centimeter also from 8 coulomb, means like option 4 will be the correct answer. It's a simple calculation based thing. Okay, now moving to the next. Two vessels separately contain two ideal gases A and B. Okay, two vessels separately contains two ideal gas A, B at temperature T. Okay, pressure of A, twice of B, twice of pressure of B, pressure of A twice of pressure of B. Okay, under the such condition, density of A is density of V. You need to calculate the molecular weight of A upon molecular weight of B. It's a simply ideal gas equation formula. Use ideal gas equation. But here you need to understand it out, like which formula you need to use it out. Okay, you need to understand this out, which formula you need to use. Okay, so you can use this formula, PV equals to rho RT. Rho is simply your density, V is your simply volume, or you can like use in this way the formula mass, you can convert it equals density equals to mass upon volume. So density equals to mass upon volume. So PV square in terms of, you can write it out in the terms of density is constant for it, and you can write in this way, PA for first formula, MA upon rho equals to RT. This is the equation for the first, and similarly for the second one, PB MB upon rho equals to RT. This is the second, and when you calculate from here that the weight of MA by MB, putting the values 1.25 and then 1.52 and other things, you get out to be MA by MW. This is the ratio that is, let's see, MA by MW, the ratio that is asked, it will come out to be 3 upon 4. You can do the calculation, you can convert it from here, that is volume, you can convert the volume in the density, sorry, P, remove it, P equals to rho, P, we have PV equals to nRT, let me check it out. Okay, mole is equals to mass upon molecular weight, okay, into RT, and there is PV, taking V here, okay, it's PM molecular weight equals to rho RT, yeah, there it will be molecular weight, this will be the formula, PM equals to rho RT, this is the formula. We can derive easily from within 1 second, no worries. Rho RT here, PMW rho RT, this will be there. You can calculate, it comes out to be 3 upon 4. Now moving ahead, question 46. It's a simply electrostatics questions. Sorry, gravitation question. Escape velocity from planet is VE. Okay, V escape. You know V escape. V escape is equals to under root of 2g mass of that planet upon R, radius of that planet. If the mass is increased 8 times, means like mass of what? Mass of, let's see, that the radius is increased to it now. Okay, mass of planet increased 8 times, and the radius of planet is increased by 2 times. So it is asking what the escape velocity. It's a simple question. The new escape velocity will be simply 2 times of initial, because once you put like new, you can calculate it out. 2g mass will increase as 8 times mass of planet, and radius 2 times. So simply it becomes 4, and 4 comes out, it becomes 2 times previous velocity. It's a simple arithmetic, you can do it, no worries. Simply 8 by 4, here you can put the radius, and it becomes to be the escape velocity, a standard formula of the escape velocity. Now coming to 47. A point charge Q is placed at the center of one face of a hemispherical zone in the flux linked with the surface. It is asking about the flux. So you know, like if like there is a hemispherical ball and there is a Q charge. If we want to cover it out, we use another spherical ball in the upper side. So from the total, we know flux total should be Q by epsilon naught, but we have only half. From the half, it should be Q by 2 epsilon naught. So the answer should be Q by 2 epsilon naught. Now we need to calculate the number of reflection that is occurring through it. Okay, number of reflection that is occurring through it. So the number of reflection that is occurring through it. Here you can see the two plane mirrors adjoining figure makes 60-degree angle with each other. Okay, you can calculate it out this way, 360 upon 660 each other. A ray falls in the one mirror, the light ray incident parallel to the angular bisector. Okay, angular bisector, okay, 30 degree. Number of reflections that light ray undergoes. Let's think. It was reflected through it, and now you can calculate it like it's perpendicular, and you can calculate it is 90 degree, it is 30 degree, and you can calculate it 90 plus 30, it's 120, and this 60. And if it is this is 60, and from the parallel axiom you can calculate it this way. No. Okay. Wait. This is 60. This is 60. Sorry. This is incident ray. This is 60. So ray will be reflect from here at 60 degree. It falls here. There will be first reflection. First mirror. When it falls, then it also reflects from the second mirror. Okay. And when it goes here, it will again reflect from the first mirror. As you can see, it is 60. Let's say one option, like it will be more than it will have more than one like three reflectors. 60, and it going down. This angle is 60 degree, and once you solve it out, it's 90. It's 30. Again, this is 60, and this is 60. Again, it falls 60. And as the plane is like a mirror gets infinitely long, so it will have an infinite like this, because the length of the mirror is not given. So you cannot say that the mirror gets over after a certain distance. If there is a mirror indefinitely, so it will have an infinite reflection. So option is not given below, but we can mark it out. Yeah, there is a given below option. So infinite will be the answer. Now moving to the 49, because you can understand now. If there is a certain length of the mirror, and then we have certain angle between certain mirror, then you can predict like how many finite reflection can occur. But if you don't have a certain length, then it will have infinite like reflections. Okay, now moving to next. If x b represent the position of mean position, velocity, and acceleration of the simple harmonic motion, then which option? A, x, and A both are maximum at extreme. Okay, you know. Yeah, it's the option is correct. Option A is x and A both are maximum at extreme. Okay, in the extreme position, x represents mean position, means amplitude. Okay, and x v all are maximum at mean position. No, A is 0. A is minimum while V is maximum at mean position. Option third is correct. Both one. Option four. Yeah. Option one is correct. Option third is correct. So both one and two. Fourth is correct option. Okay. Now a body is projected at such an angle horizontal. Okay. The body is projected at such an angle that the horizontal range is 3 times the greatest height. Okay, you need to find, okay, you need to just use the formula. Horizontal range is 3 times, so simply you can use also this formula, tan theta. Tan theta equals to 4h upon r, and when you put it out, it becomes 4 by 3. 4 by 3, tan 4 by 3, tan 4 by 3, you can simply say it to be 53 degree angle, because you know like base is big, 4 3 37 5, it's 53. So you can calculate the tan 53, it's become 4 by 3. So its theta will be like 53 degree angle. So 53 will be the answer. And here we will have all the solutions of question 50 questions you have. The most important thing that are concerned here is about the concept and the analytical thinking required. Some of the calculations are left on you. You can easily do the calculation and understand it, but I have given the answer to you as I have calculated already. You need to understand the concept behind it and the reasoning going. And some, if some like pictures or get hidden due to my photo, so you can easily understand it or do it by yourself, because I have already explained you the concept behind it. So these are all the solutions of 50 questions. I hope you will find it good and helpful for you. And if you find any mistake, you can easily comment it, and I will try to like resolve it or reply you on the comment, so that you can easily understand the concept and your misconceptions will be removed. Thank you very much.